Welcome to the Explainer. So, I want you to picture this for a second. It's Diwali. A young kid named Harish is at this incredibly bustling market, and he's just completely overwhelmed by the sheer volume of stuff. Shoes, clothes, utensils, diyas everywhere. He turns to his dad and asks this super simple yet, honestly, profound question. How can so many things be made in such massive quantities? That everyday moment, that sudden realization of mass production, well, that's exactly what we're unpacking today.
I mean, it's the perfect grounding question, isn't it? How exactly does a market get flooded with so many different products right when we need them? To actually answer that, we have to kind of zoom out from Harish in that crowded market and look at the massive macroeconomic reality behind it all. We're talking about the factories, the complex supply chains, and this immense industrial effort that just quietly hums in the background of our everyday lives.
And that brings us straight to the core concept here, manufacturing. By definition, we're talking about the production of goods in really large quantities, after processing them from raw materials into more valuable products. Just think about the incredible alchemy going on here. You take primary materials that might not be all that useful on their own, like a rough splintered piece of wood or some raw sugarcane, and through processing you add immense value. You literally turn that wood into the paper you're writing on, or that sugarcane into the sugar for your morning tea. It's the ultimate value add.
So here is our roadmap for today. We'll start with the engine of development, then move on to classifying the industrial world. After that, it's from fields to factories, followed by minerals, metals, and microchips. And finally, we'll wrap up with the environmental cost and cure.
All right, Section 1, the engine of development. Let's get right into it.
So why exactly does manufacturing act as the indispensable motor of a nation's economy? Well, a country's economic strength is quite literally measured by its manufacturing industries. First off, it modernizes agriculture, which is the traditional backbone of the economy. These two really move hand in hand. By supplying farmers with absolutely vital tools, things like irrigation pumps and fertilizers, manufacturing significantly boosts agricultural productivity. And in turn, it creates secondary and tertiary jobs, which takes the pressure off of agricultural income. This is a crucial precondition for eradicating unemployment and poverty. Plus, when a country exports those manufactured goods, it expands trade and brings in a ton of much-needed foreign exchange. Ultimately, the countries that figure out how to transform raw materials into a wide variety of higher-value finished goods, those are the ones that achieve true prosperity.
Moving on to Section 2, classifying the industrial world.
Now, it's really fascinating how we can take this chaotic web of literally millions of factories and cleanly classify them by what they actually do. Take basic or key industries, for example. These are your heavy hitters: iron, steel, copper smelting. They supply their own products as raw materials to build other machinery. Now contrast those with consumer industries. These produce goods for direct, everyday use. The sugar, the toothpaste, maybe the electric fan you turned on this morning. That's all consumer industry right there.
We can also classify them by who actually owns them. The public sector consists of industries owned and operated by government agencies. Think of BHEL or SAIL. On the flip side, the private sector is owned by individuals or corporate groups, like Tisco or Bajaj Auto. But you know, the landscape is way more diverse than just public versus private. You've got joint sector industries like Oil India Limited, which are run by the state and private individuals together. And then, and this is super interesting, we have these massive cooperative sector industries. These are actually owned and operated by the producers or suppliers of the raw materials themselves. They pool their resources and share the profits or, the losses. The highly successful sugar industry down in Maharashtra is a prime real-world example of this cooperative model in action.
Which brings us to Section 3, from fields to factories.
Industries like cotton, jute, and sugar rely directly on agricultural raw materials. But to really grasp their immense scale today, we need to trace the historical milestones that took India from traditional handloom weaving right into a modern industrial powerhouse. Going back to 1854, that's when the first successful cotton textile mill was set up in Mumbai. Just a year later, in 1855, the first jute mill pops up near Kolkata at Rishra. And pushing into the broader, heavier industrial landscape, by 1904, we see the first cement plant established in Chennai. These early factories were absolutely game changers. They were the sparks that ignited India's broader industrial revolution, quite literally moving workers straight from the fields and onto the factory floors.
Now, looking a bit closer at an absolute agro-based giant, the sugar industry, we're seeing a really fascinating geographic trend right now. India is the second largest producer of sugar in the world, but recently there's been a major shift. The mills are actually moving away from their traditional northern strongholds and heavily concentrating in the southern and western states, particularly Maharashtra. So why the move? Well, geography and climate totally dictate success here. The cane produced in these southern and western regions actually packs a higher sucrose content. Plus, the cooler climate guarantees a much longer crushing season for the mills. Combine that with the fact that those cooperative ownership models we talked about are highly successful in these states, and you've got the absolute perfect recipe for an industry shift.
All right, let's pivot to Section 4, Minerals, Metals, and Microchips.
At the very heart of this sector beats the iron and steel industry. It is the fundamental building block of modern infrastructure because all other industries, heavy, medium, light, you name it, completely depend on it for their machinery. But to forge this vital metal, you need a highly specific recipe. To produce heavy, bulky steel, you need raw materials in an approximate ratio of 4 to 2 to 1. That is 4 parts iron ore, 2 parts coke and coal, and 1 part limestone. And because all of these raw materials and the finished steel itself are incredibly heavy and bulky, the industry faces absolutely massive transportation costs. That's exactly why you see such a heavy concentration of iron and steel plants in places like the Chotanagpur Plateau. It offers incredibly close proximity to high-grade raw materials and, of course, a reliable labor force.
Beyond just steel, modern manufacturing is an incredibly diverse landscape, with each sector having its own highly specific needs. Take aluminum smelting, for instance. It's the second most important metallurgical industry, and it relies on this bulky, dark reddish rock called bauxite. But its absolute biggest requirement? A massive uninterrupted supply of electricity. Meanwhile, you have the fast-growing chemical industry, which requires its organic chemical plants to be strategically located right next to oil refineries or petrochemical plants. And then, of course, we have the information technology and electronics industry, defined by explosive growth in hardware and software. This sector requires top-tier talent and tech infrastructure, which explains exactly why Bangalore has firmly established itself as the electronic capital of India.
Finally, we reach Section 5, Environmental Cost and Cure.
Suddenly, we have to pivot here. We have to look away from the incredible wealth generated by this economic engine and face the stark reality of its exhaust. The industrial growth that builds nations unfortunately brings with it severe environmental degradation, usually across 4 distinct culprits. First, air pollution, driven by toxic gases like sulfur dioxide. As history tragically reminds us with events like the Bhopal gas leak, this can be instantly hazardous and leave devastating long-term health effects. Then there's water pollution, where chemical plants, tanneries, and refineries are literally dumping heavy metals, acids, and dyes right into our rivers. Closely related to thermal pollution, that's where boiling hot water from factories is drained directly into ponds, which completely devastates aquatic life. We also have land pollution, where the dumping of harmful chemicals and industrial glass renders soil utterly useless. And lastly, noise pollution. The constant roar of massive machinery and generators acts as a severe, ongoing physiological stressor for anyone living nearby.
To really grasp the scope of this water issue, it all comes down to one deeply alarming ratio: 8 to 1. Every single liter of industrial wastewater discharged pollutes exactly 8 times that quantity of precious fresh water. Seriously, let that sink in for a moment. Just 1 liter of toxic exhaust ruins 8 liters of our absolute most vital life-sustaining resource. It's a ratio that we simply cannot sustain long-term.
But there is a cure. We have a logical, engineered process to save our water systems. Treating these industrial effluents requires a rigorous 3-phase tune-up. Phase 1 is the primary treatment. This uses basic mechanical means, things like screening, grinding, and sedimentation, just to remove the solid waste. Then we move to Phase 2, the secondary treatment. This utilizes biological processes to naturally break down organic matter in the water. And finally, Phase 3 is the tertiary treatment, which combines biological, chemical, and physical processes to thoroughly clean and ultimately recycle that wastewater. Yes, it requires serious investment, but it is entirely necessary if we want to break that brutal 1-to-8 pollution ratio.
And water isn't the only fix. We have critical solutions across the board. We can dramatically reduce particulate matter in our air just by fitting factory smokestacks with electrostatic precipitators and scrubbers. We can cut down on smoke by transitioning factories away from coal and towards oil or gas. We can even curb that noise pollution simply by redesigning equipment and fitting heavy machinery with silencers. And the best part is, major corporations are already proving that this is entirely possible. Just look at NTPC, a massive power-providing corporation in India. They hold a highly proactive ISO 14001 certification for environmental management.
They are actively integrating their economic development with deep environmental concerns. They're doing ecological monitoring, ash water recycling, and even creating massive green belts. They're proving out loud that sustainable development isn't just some corporate buzzword, it can be an operational reality. So, we started this whole journey in a bustling Diwali market with young Harish, completely amazed by the sheer volume of manufactured goods all around him. And together, we've seen how this incredible engine of production cures poverty, builds modern infrastructure, and completely transforms raw materials into lasting national prosperity. But we've also had to stare directly at the dark exhaust it produces, the severe toll it takes on our air, our water, and our soil. Which leaves us with this final vital question to ponder. As our population continues to grow and our daily demands increase, can we truly balance our immense hunger for manufactured goods with the actual survival of our planet? It's the ultimate challenge of sustainable development and a question every single one of us needs to weigh as we navigate this modern world. Thank you so much for checking out this explainer with me today. Keep asking those big questions, and I'll see you next time.